Hello everyone, welcome to AI Exact channel. This is Akash Gangwar and today we'll be covering Trigonometry lecture 4, where we'll be studying about multiple submultiple angles and certain examples and results related to that. So this is question 7 of the QOD series. Just take a screenshot for the same. And now let's start discussing the multiple angles. So the first category is double angle. Sine to theta, cos to theta, tan to theta. Now the derivation is very simple. I'll write 2 theta as sine of theta plus theta. So that will give me sine of a plus b, right? So that is sine a cos b plus cos a sine b. That is nothing but 2 sine theta cos theta, right? So the derivation is very simple. You can do the same for cos 2 theta and tan 2 theta. Now, interesting part about cos 2 theta is we can transform into only sine square or only cos square formulas. So if I write cos square theta is 1 minus sine square theta, so I'll get 1 minus 2 sine square theta, which is same as 2 cos square theta minus 1. If I transform this into cos, then this will become 2 cos square theta minus 1. So you can use any of these three. Tan 2 theta is 2 tan theta upon 1 minus tan square theta. That again comes like this only. Tan of theta plus theta. Tan a plus tan b upon 1 minus tan a tan b. Now these are some alterations in case of these formulas. So how do we get it? So we know that sine of 2 theta is 2 sine theta cos theta. I'll show one derivation. You can do the rest. Now what I'll do, I'll multiply and divide by cos square theta. So clubbing this will become 2 tan theta, right? And I can write cos square theta as 1 upon sec square theta. Now we know that sec square theta is 1 plus tan square theta. So that comes out to be 2 tan theta upon 1 plus tan square theta, right? So you can write sine 2 theta in terms of tan theta as well. Similarly, you can write cos 2 theta as 1 minus tan square theta plus 1 divided by 1 plus tan square theta. Similar kind of derivation. Just write the basic format cos square theta minus sin square theta and divide by and multiply by cos square theta. Now let's look at triple angles. Sin 3 theta, cos 3 theta, tan 3 theta. So let's look at the derivation of sin 3 theta. Both of them are similar, right? So I'll write 3 theta as 2 theta plus theta. That is, we can apply sine of a plus b over here. So that is sin a cos b plus cos a sin b, right? Now I'll write sine 2 theta is 2 sin theta cos theta, and cos theta dot cos theta is cos square theta plus cos 2 theta. I'll write this in sine forms because we have to prove in sine forms, right? So I'll write it as 1 minus 2 sine square theta dot sin theta. Now I'll write cos square theta as 1 minus sine square theta plus this becomes sine theta minus 2 sine cube theta. Now this 2 sine theta and sine theta gives us 3 sine theta, and 2 sine cube theta and 2 sine cube theta gives us minus 4 sine cube theta. So this is how you can also prove cos 3 theta and tan 3 theta. Now let's talk about submultiple angles. So these are nothing but just simple alterations of multiple angles. So initially what we did, we wrote sine 2 theta as 2 sine theta dot cos theta. What we are doing over here is we're writing sine theta as 2 sine theta by 2 dot cos of theta by 2. Same thing, right? Because we have just replaced 2 theta as theta over here. So that's why it becomes theta by 2 over here and theta by 2 over here, right? So there are no changes in the formulas. All of them are similar. You just have to make sure that you are writing correct submultiple. Now let's look at this illustration. It says sine cube theta plus sine 3 theta divided by cos cube theta minus cos 3 theta. So I'll expand sine 3 theta and cos 3 theta. So this becomes sine cube theta plus 3 sine theta minus 4 sine cube theta divided by cos cube theta minus 4 cos cube theta minus 3 cos theta. Now what we can do, we can pull out 3 sine theta common over here, and we'll get 1 minus sine square theta. Similarly, in the denominator part, we'll plug out 3 cos theta and we'll get 1 minus cos square theta over here. So what this becomes is 3 sine theta dot cos square theta divided by 3 cos theta dot sine square theta. So you can see that this is nothing but cot theta, right? So B is our correct option. Now let's look at another example. So we'll start with the first under root sign over here. So this is nothing but 2 times 1 plus cos of 8 theta under root. Now whenever I see something like that, 1 plus cos 2 theta, my mind automatically triggers 2 cos square theta, because cos 2 theta equals to 1 minus 2 sine square theta equals to 2 cos square theta minus 1. So whenever I see something of these sort, my mind automatically triggers this one, just the habitual part. So even if it doesn't make sense over here, it might not have made sense over here, but just make a habit. If you see something of this sort, 1 plus cos 2 theta, 1 plus cos theta, your mind automatically should trigger 2 cos square theta. Now here it's written that 1 plus cos 8 theta, which is nothing but 2 cos square 4 theta. So what we'll get, 2 dot 2 cos square 4 theta. So this will come out to be mod of 2 cos 4 theta. Why mod? Because anything under root which is having a square, that comes out as mod, because under root is always positive, right? Now to open the mod, we'll have to check where this angle is lying. So we know that theta is lying in the range of 0 to pi by 16. So 4 theta is lying in the range of 0 to pi by 4, which is acute, right? So if this angle is acute, so cos value will be positive. So that's why this mod will be opened as 2 cos 4 theta. Now you can apply the similar iteration over here. So this becomes 2 cos 4 theta, and this is 2 plus 2 cos 4 theta. You can take 2 again common, and you can write it as 1 plus cos 4 theta. So that again triggers 2 cos square 2 theta. We'll again check if the angle is in the range of 0 to pi by 2 or not. If that is the case, then the mod will open as positive. So in this one, we'll get 2 cos 2 theta. And for this one, we'll get 2 cos theta, right? So D is the correct answer. So you just have to observe the pattern first, and you can apply similar pattern for the entire under root. Now let's look at some important results. Sin theta, sin 60 minus theta, sin 60 plus theta equals to 1 by 4 sin 3 theta. Now how to derive it? Whenever I see something of this sort, sin 60 minus theta dot, so basically sin of a minus b and sin of a plus b. I'll use the next page. There is no space over here. So basically it is written as sin theta dot sin of 60 minus theta dot sin of 60 plus theta. So whenever I see something like this, sin of a plus b dot sin of a minus b, my mind automatically triggers sin square a minus sin square b. We'll do the same. Sin theta sin square 60 minus sin square theta, right? So this is nothing but 3 by 4 minus sin square theta. If we take LCM, what we'll get? Sin theta 1 by 4 over here, 3 minus 4 sine square theta. So this is nothing but 1 by 4 3 sine theta minus 4 sine cube theta. Now this is sine 3 theta, right? So we'll get 1 by 4 sine 3 theta. Exactly same derivation for this cos part. So we can generalize it sine theta, sine 60 minus theta, sine 60 plus theta, regardless of the angle, equals to 1 by 4 sine 3 theta. Same for cos. Now for tan, we'll divide both of these equations. So that's why 1 by 4 will be removed. And even for cot, same kind of generalization can be made, and 1 by 4 will not be there. So cot theta, cot 60 minus theta, cot 60 plus theta equals to cot 3 theta. Now let's look at one last example. Value of cos 20 plus 8 sine 10 sine 50 sine 70. Now I can see that this is theta, this is 60 minus theta, and this is 60 plus theta. So make it a habit. If you see 3 multiplications, then try to see if this is the format or not, right? So just make it a habit. Whenever you see any 3 multiplications in terms of sine or cos or tan or cot, just make it a habit that you try to fit in this formula. That might get things simplified. So this is cos 20 plus 8 times sine of 30 by 4, right? Sine 3 theta. Here theta is 10, so sine 30 by 4. Now sine 30 is itself 1 by 2. So this is cos 20 plus 8 into 1 by 4 into 1 by 2 divided by sine square 80. Now you can see that this is 1. Now again, we come at the same thought process. Whenever I see something of this sort, 1 plus cos 2 theta, 1 plus cos theta, my mind automatically triggers 2 cos square theta. And that fits over here as well, right? Because we have a sine square term over here, but we don't have a square term in the numerator. So now I can see that this is 2 cos square 10 divided by sine square 80. And these are complementary angles, so we can cancel them out. So 2 is the answer, right? So today's lecture was till here only, and I hope you are enjoying the series. So along with taking these lectures and examples, I'm also giving hints on how to train your mind to give you triggers based on the patterns or based on the things you are seeing in mathematics, especially in trigonometry, because there are so many formulas. Then you should have certain kind of thumb rules before solving a particular question or any question in trigonometry. So that will help you out in the entire process. So today's lecture was till here only, and we'll meet tomorrow for the last lecture of trigonometry. That will be based on, I think, series summation and transformation formulas. So let's catch up tomorrow. Thanks for watching.